Every year, thousands of giant cargo ships vanish from the sea. They are deliberately steered away from the open ocean, guided into massive concrete trenches. To survive the relentless corrosion of the saltwater environment, a vessel must periodically be removed from the water, inspected, and rebuilt from the bottom up. This process happens inside a ship repair yard. It is a massive engineering ecosystem where thousands of specialists execute a tightly sequenced, heavy industrial choreography to restore a vessel's structural integrity. Entering a dry dock represents a technical reset. It allows engineers to access and maintain the hull sections that are otherwise unreachable for years at a time. This maintenance is particularly critical in Indonesia. The nation is an archipelago of more than 17,500 islands, separated by some of the world's most vital sea lanes. Across this geography, ships function as non-negotiable infrastructure. Ferries and cargo vessels move people, food, and fuel, acting as the physical bridges connecting the nation's economy. Indonesia relies on multi-purpose shipyards like PT PAL and Dock Surabaya to support these fleets. These facilities are designed to manage a vessel across its entire life cycle, from its initial construction to its final recycling. Without these yards acting as regional maintenance hubs, the wear and tear of the ocean would eventually collapse the supply chains of this island nation. The repair sequence begins with a high-stakes arrival. Dockmasters guide the floating hull into the flooded basin, aligning it precisely over a hidden grid of heavy structural supports called keel blocks. Industrial pumps extract millions of gallons of seawater from the dock. As the water level falls, the ship's immense weight settles onto the blocks. With the basin empty, the ship is seen in its entirety. The lower hull reveals a structural body that is normally hidden beneath the waterline. Engineers immediately begin their physical inspections. They examine the steel plating for microcracks and inspect the sea chests, the intake recesses used for cooling water, along with thousands of mechanical valves. Draining the ocean away is the ultimate prerequisite for truth in marine engineering. It strips the ship down to its bare physical reality. Beyond the steel itself, engineers must confront a relentless biological adversary. Over time, millions of organisms like barnacles and algae attach to the steel, forming a thick layer of biofouling. This biological layer disrupts movement. Water glides over a clean hull, but biofouling creates severe turbulence. This friction has a real cost. As drag increases, the engine burns more fuel to maintain speed, causing a direct spike in carbon emissions. To restore performance, shipyard workers use high-pressure water jets to blast the biological growth and damaged coatings directly off the steel. Blasting the hull back to bare steel restores the ship's hydrodynamic profile. This process directly lowers the energy required to push the vessel through the water for the next several years. Moving deeper into the drained dock, the focus shifts to the ship's skeleton. Years of exposure to salt water inevitably lead to localized corrosion and structural decay. Workers execute steel renewal by physically cropping out wasted or corroded sections of the hull and welding newly fabricated steel inserts back into the structure. At the rear of the vessel, engineers work on the rudder. This massive control surface directs water flow and is the primary tool for maneuvering the heavy ship. Damaged or misaligned rudders can compromise steering reliability. Repairing them requires heavy shipyard cranes to support and lower tens of tons of steel with surgical precision to realign the shaft bearings. This steelwork is where industrial scale meets mechanical tolerance. These repairs ensure the safety of crew and cargo against the forces of the open ocean. Once structural repairs are finished, painters apply specialized protective coatings. Then the dock valves are opened and seawater violently floods the basin. As the water level rises, the ship regains its buoyancy and lifts off the keel blocks, ready to return to service as a renewed structure. This maintenance period injects years of additional operational life into the vessel, a concept engineers call maritime resilience. This chart highlights the circular economy of the shipyard. Repairing existing ships is more resource efficient than the mining, forging, and energy-intensive construction required to build a new replacement. Multi-purpose shipyards operate as stabilizers for maritime trade. By integrating construction and maintenance, they maximize the service life of global resources and maintain the flow of international commerce. The renewed ship clears the shipyard gates and re-enters the interconnected logistics network of the Indonesian archipelago. While this vessel will sail for another decade, every machine eventually reaches its absolute structural limit, where repair is no longer viable. When that day comes, the ship must be permanently retired. In our next episode, we ask the final life cycle question: when a ship can no longer be fixed, where does it go to die?